Before I formally start talking about what we're doing, actually I'll share a little bit of my experiences. Yeah, the whole thing actually started from 18 years ago when I was at Microsoft designing something called .NET. So I give a little bit of history about why we started that project, right? The name of it is called .NET, meaning it's not, has network in mind. Actually, in 1992, Sun Macro designed, the author of Java programming language, came up with the slogan called the network is the computer. Because at that time, people didn't really pay that much attention to it. But 1992 was the year actually Mosaic was first came to this world. And of course, later on, Netscape was grown out of Mosaic in 1995. It went public and the stock went up to the roof, right? And that said, actually by 1998, Microsoft started to design something called, to think of it as a network, as a computer, and built the .NET framework. Unfortunately, the project, in a way, to a lot of people, hello? Yeah, it was a failure. But then it's been 20 years. There's some background here. March of this year, Microsoft announced that they are disbanding they were disbanding the Windows team. I don't know how much have you heard the news. Microsoft has no Windows team no more. Have you heard? No? Okay, then here's something really deserves some mentioning because of, it's on the news, right? Not only, I thought it's only Chinese media didn't pay attention. Unfortunately, the American media didn't do a good job either because Microsoft doesn't have a Windows team anymore, okay? It's gone. Then people should ask why, okay? Because for such a big corporation, getting rid of its Windows team is no small take, right? And whether you like Microsoft or not, doesn't really matter, but then it deserves some research. That said, actually there was a company called Xerox. Once upon a time was very, very popular and powerful. And Xerox in the 1980s, when I first came to this country in 1994, January of 94, actually, Xerox was so popular, right? Xerox invented three things, Windows and Ethernet, and then the object-oriented programming. Basically, Xerox had designed a mouse and designed the Windows interface for the Windows, and also invented the so-called Ethernet, right? The network we're using today, and also the object-oriented programming at that time called Smalltalk 80. And three things was very, very popular, but then the company went pretty much down under. And people overlooked the facts that the same thing could happen to Microsoft, even though the stock is doing okay. But then when they had money to do research, I know a lot of people call them evil, but they did indeed something at least meaningful to me, right? I'm a true believer of the .NET vision, even though the technical route it took, I didn't really agree. So that's why I left Microsoft year 2000. And then I'll start talking about Elastos. The name of Elastos, I came up with the name in 2002, 2 years after I launched this project. At first it was started by something called, some nickname in Chinese, but then I came up with the name Elastos in 2002 on a flight from China back to Seattle. Then I can explain why, what's the meaning behind it, right? By Elastos, of course, First, it means something called elastic compute. And elastic compute was really the term used by Amazon in 2006. That was, what it says is you can create virtual machines in the cloud, right? What's the cloud? It actually was a server farm. Like, say, a cloud center has about 10,000 hardware PCs. Then on top of this 10,000 hardware PCs, you could literally launch 100,000 virtual machines on demand, or kill some of them also on demand, right? It's elastic, depends on how many people log in, and you launch more virtual machines and destroy them according to the demand, right? So it's called elastic because it's a creation or deletion on demand. But now, when we talk about it today, we're talking about, because it's a virtual machine, right? And now given the PCs or the smartphones, comparing 2006, where like literally 12 years later, right? Our phones can run multiple virtual machines now, PCs as well, right? So could we do virtual machines spreading out the web from the phone back to the cloud? We don't really limit the virtual machines only running in the cloud, right? Could be on a smart router, could be on your phone, so could have a ubiquitous deployment of virtual machines. That's the first meaning of Elastos. So we built virtual machines across the board. And that's why we start to build something I named it called Smart Web. Smart Web meaning the web that runs apps, right? Because like a smartphone is a phone that runs apps. So that's why I named it Smart Web. Secondly, when we talk about Elastos, if you spell it carefully, there's a pun, Elastos, right? Actually, the reason why I named it that way, I mean, it's just a coincidence, but then even back 20 years back, dated back to the Microsoft years, we pretty much had the hunch it'll be the last. Okay, 20 years back, literally. Because when we design an operating system for the network, we cannot, absolutely not. You cannot have versioning. Let's say, because if you have one machine at that time was a Windows 2000 in alpha beta stage. If you have a Windows 2000, you have device drivers, okay? And you put in a printer, you put in a projector, then at that time, remember the back days, 1995, 1998, and year 2000, they require you to update your drivers. And if you upgrade your operating system, the operating system will ask you to update the device drivers as well. But if you're talking about a network OS, you cannot dictate the versioning of websites. You cannot dictate the versioning of, say, the projectors of this room, right? Let's say I came up with an older machine or newer machine. Can I ask the driver of a projector to upgrade or downgrade on demand? I couldn't. So then that's where you have to research on, can we do an operating system without drivers, without dictating the versions of drivers, right? In a way, what we're saying is, can you design a system without drivers at all? And the basic idea is that actually, when we were in school back in the 70s, late 70s, at that time, the terminals were called dummy terminals. Have you heard about the term dummy terminals? Anyone? Or no? We're too young. Because then I'll just basically giving you what was going on at that time. In the 70s, the CPUs are so expensive, right? We can only afford to build one. And then the displays. If you see the 007 James Bond movies, right? They have those teletypes. You know, this, what was the intelligence office giving orders, and then you see the little typewriter, right? It's electric typewriters that typing up those secret messages. And at that point, it's really by something called a serial line and parallel line, literally by copper wires, by the power voltage, high and low, representing 0 and 1s, and by the combination of the wires, then having the relay to suck the mechanical arm and then giving you typing A, typing B. So at that time, all peripherals were dummy, meaning without CPUs. And without CPU, then somehow the translation between a message into the mechanical actions actually are done by a piece of software has to be on the motherboard because of the typewriter was dummy. And also, when you have a display, right, like black and white or amber at that point, and it doesn't really have a CPU built in. It's pretty much like those vacuum tubed TV, right? And so they are called dummy terminals and dummy peripherals. Then there's only one place we put drivers. That was the motherboard. So that's why drivers were built into the operating system. I know people should know about Linux, right? And Linux, actually, the predecessor of Linux is called Unix. And Unix research started in either 1969 or 1970. Actually, the internet was also started around that time. They're about a year apart. One of them is 1969, the other one is 1970. So what we're saying is today's technology is just as backward as the 70s, and it haven't changed, okay? So the operating system research, really what we're using today, even though a lot of people are saying Linux is so advanced, so powerful, actually, they're just as powerful as 40 years ago. It's the same thing, which haven't done any drastic changes since then. And by 1998, when we designed .NET, we think we could fix it. So by something called software as a service. So meaning all peripherals are smart with a CPU, and we can treat them as services. Services meaning they can be replaced. They can be, let's say, if what's a service, right? Service is something as long as you can replace them with a different one. Say I can use this printer or I can use a different printer. You put in with the standards. You hook up the serial line and to a consumer, they look the same, right? So comparing to you have a generic battery with you have a brand name battery. As long as the battery is swappable, we call them a battery as a service. So that's basically the definition of software as a service, meaning the software module could be replaceable. That was the idea. But what's going on here is so long as they're replaceable, right? We don't really care about whether the battery is which version or what year it's produced. So that's why following the concept, and we had a hunch we could design an operating system without versions. Okay, now we're fast forward to March of this year, right? The reason why Microsoft doesn't have a Windows team no more is because if you read the news more carefully, they divide the team into two halves. One is they push the kernel, everything into devices. And so when we buy a phone, when we buy a machine, a computer, when we buy a projector, it has a built-in kernel, built-in BIOS, and then everything else, right, it's on-demand loading the virtual machines on demand. So the virtual machines belong to the cloud, and the kernel built into the device. So that's why there's no more Windows, which means no more buying a computer and installing operating systems, right? So you buy a phone, whether it's Android or iOS, you don't really install OS anymore, correct? So on a PC, you're not going to install Windows anymore, right? So that's why they don't have a Windows team. That's the reason why it's related to Elastos, as I mentioned. First of all, it's a virtual machine spread across the board. And secondly, the devices, they don't have versioning, so they can build into the BIOS, the firmware. That's basically the conclusion. We don't have to go into technical details. Then we fast forward to giving the presentation, what we're doing today, right? And we are building something called smart web. Smart web meaning the internet. And internet, when people talk about the last internet was something called information internet, which meaning information at your fingertips. You can click a URL, you get some web pages, or you can share data through your social network. Say on Facebook or on WeChat, you can send video, you can send pictures between peers. And internet of information, everything actually you shared is data. But then now people talk about information of value, right? Because if you did something, research on blockchain, people could finally sharing like Bitcoins peer-to-peer without an intermediary, and people claiming that's sharing value peer-to-peer, right? That said, if you think a step further, especially when we are in Hollywood, and when we share anything larger than a number, anything like a movie, a book, a game, of course it's a blob of code, right? It's a bunch of files together, and that's more than a number. When we share two numbers together, and actually, if I send you a number, a Bitcoin, actually there's a code which interprets what that one means. There's a blockchain called Bitcoin blockchain, right? That code is running on 10,000 nodes owned by no organizations, no governments, and no individuals. It's a consortium or owned by a community. And then we share a value, one from me to Fei, but then the number is interpreted by that community who runs the decentralized ledger. So then when I send you one, meaning we also, not only I send you one, we also have a common shared code, not owned by government, not owned by individuals, right? So keep that in mind. But when I share a movie between one party to another, who's owning the code, interpreting the movie? If I send you like a H.264, H.265 movie, if I send you the movie peer-to-peer, can I do that with the existing internet? Of course I could. When I send the movie from one party to another, first thing happens is fairly often, right? And people do the first direct piracy. Direct piracy meaning if you send me your movie, I could freely make a duplicate and send it to someone else. And if you want to sell me the movie, if you want to sell me that copy, you sell me once, then I make a duplicate, I sell it, I give it to someone else, right? Without abiding by your rules that you told me, oh, you know, I sell it one for your eyes only, you cannot resell it. I say, okay, fine. You sell it to me, but I kind of ignore it, then I piracy it. It's a first degree, right? First piracy. And then the second piracy, indirect piracy would be, okay, since I don't trust you, I cannot give you the movie, then who should I give? I give to the channel. I give to the media player, right? And who is claiming then, let's say, I don't want to name names, but then say a website. And you give your content to that website, hoping to monetize the movie you made. And then, of course, the website will sign a contract saying every time the movie being played, I give the author a cut, correct? But there's an indirect piracy, meaning fairly often the website may not telling the truth. It's played by a consumer like a million times. then the website could say, okay, it's being played only 10,000 times, right? Because they didn't give me the cut, then it's a pure profit for the website, correct? It happens, right? I've heard the news like a movie showing in theaters and people have an argument going on to court. In fact, how many audience watched? There's a argument between the author and the channel. So it's called second indirect piracy. So long as I don't own the code, then I don't really own the right. When we say we share value peer-to-peer, and especially in the blockchain ages, people are saying you own your own data, right? Well, I'm adding one more claim. If you don't own the code, you don't really own your own data, correct? Without owning your data, you don't have the right. You don't know how many times being played. So then the solution I'm proposing is that you send code peer-to-peer. You have the movie. You scramble it. Actually, it's not that hard for a computer science student. The project should be able to, it's not as hard as if someone graduated from college with a college degree, it should be able to do it, right? To give you a movie, scramble it into a game. It generates a game, which meaning I give it a movie, the tool will give me back a game. The game is so simple that it has only fast forward, fast backward, rewind, pause, play. Only that limited functionalities. And then giving that game, I share peer-to-peer to someone else. And then the guy who received the game, plays it. And if I play once or play a million times, I got a message back, right? Every time plays the movie, it sends me a message saying it played once, played twice, played 3 times. And so long as it's a game, it can send me a message back home. But then the problem is, given the operating system from the 70s, one thing we noticed that is there are lots of viruses. We all learned our lessons. If you send executables through email, which is achievable 40 years back, right? You can send email, send exe, executable file through email. And we all know, people warn us, don't click on it. If you click on it, very likely your machine will be infected with virus. So that's the first challenge. How do we send code peer-to-peer without spreading viruses? That's the challenge number 1. The second one is, because of its code, we have to load it. You load the code, giving operating system a chance. When we load you, we go check the blockchain, whether you still own it. If you own it, we'll play it. If you don't own it, I mean, if you sell the movie to me, you don't own it anymore, even though you have all the bits on your hard drive. But then it needs to be executed, right? Only one virtual machine plays it. And the virtual machine, when it plays it, it'll check against the blockchain. Okay, you don't have the right. You don't play it anymore. So which meaning the operating system is different from 20 years back, right? Because at that time, if you purchase an Office, you can play it 1 million times if you wish. But with the blockchain, we can limit the number of times you play the content, which really, then later on I'll mention about the blockchain, right? We can create something called a scarcity. So we create limitations on the times the movie could be played, which is really the key to create a private asset. If I own the movie, I own the right, I own a piece of asset, as if I own a hard copy book. If I purchase a book from Amazon, and I can resell it because I own that piece of property. I can dispose it any way I like. So I own it, ownership of private asset that I own. But then today, if you buy a ebook from Amazon, you don't really have the right to resell your ebook, not as you resell your hard copy paperback books, right? So that means if you buy a paperback book, you own it. If you buy an ebook, you don't really own it. You lease it for your lifetime, which has a different meaning to it, right? You don't really, currently on the internet, nobody owns anything except the big corporations. But paperback books, we literally own it, right? That's a capitalism, right? Your ownership of something really doesn't exist on the internet. That's how big the problem is. Can we solve the problem, right, given the blockchain technology? So then, after that, I will mention, this is the first point I'm trying to pass through. Second point is that when we talk about internet of value, we're emphasizing on the word internet. Internet meaning it's a multiple nodes. A network meaning you have multiple nodes, multiple parties connected to one another, all right? So that's a network, meaning on this internet, right, you have Google, you have Apple, you have Yahoo, you have Microsoft, right? They have different companies and individuals. We are all interconnected. Each of those big companies I mentioned, they have millions of computers inside them, logically, right? So we have two aspects, two points looking at exactly the same thing. Let's say if I look at this phone, we all know there's a quad-core, octa-core built into the machine. So for a chief engineer point of view of this machine, it has a quad-core, right? There are messages between the core A and core B, core 1 and core 2, correct? So inside the machine, it's decentralized, it's distributed, but yet to a consumer, this is one machine, right? So regardless of how many machines Google has, we treat them as one entity. So we're talking about multi-parties of internet. We're not really talking about Google has 1 million of computers. Google is just one node called google.com. As if, let's say google.com has a search bar. Let's say, okay, let's search what is Elastos. Literally, that search is done by millions of computers in parallel, which we don't really care as a consumer. The reason why I'm emphasizing this point is to a lot of people doing background research on blockchain, I know especially people here may not be as technical as like Vitalik or BM, right? Bitmaster. To them, even lately, Vitalik wrote an article saying, physically, Ethereum is decentralized and distributed because it has 6,000 to 1,000 to 10,000 nodes distributed all across the world. But logically, Ethereum is a centralized ledger. I emphasize, that's Vitalik's word. It's a centralized, logically, a centralized ledger. Because a lot of people saying Ethereum or blockchain, they're decentralized, which is actually not true. Because one ledger, it's just one ledger we can have more trust into. Logically, that ledger is not much different from a ledger of Bank of America. It's just we have less trust into the ledger of a Bank of America, okay? So when we write a transaction, I send you a Ethereum or send you a Bitcoin from one another. That's just a very simple transaction. From point A to point B on a certain date with both parties' signatures and with a remark field, right? On an average of about 250 bytes. So that's one transaction. And every 10 minutes, we build a block for Bitcoin. So that's about 4,000 transactions. Just as simple as that, okay? Remember that. Bitcoin is not that difficult. It's just very simple to understand. Then every 10 minutes you have page, every 10 minutes you have page, then you build up a ledger. That ledger is stored on 10,000 nodes. We can trust more because no one can turn it off, no one can manipulate. Comparing to Bank of America, we deposit a check, point A to point B, with both signatures on a date and with a remark. And so actually the Bank of America, when they deposit a check, the meaning of it, really the two are equivalent. It's just one which could be manipulated, right? Could be ordered by the Bank of America. The check could be lost. So that what I'm saying is the blockchain, we have more trust than the Bank of America, but both of them are centralized. Both of them are one ledger, okay? We have to emphasize that because one blockchain could never build a distributed system because it's a one ledger. To build a distributed system, we really have to talk about multiple parties. Then we talk about decentralized. Who's the big boss? Who is the big brother? Google, Apple, Microsoft, Amazon, right? Who is the bigger brother? Somehow between them, they have to build a trust. In China, they have to be like Tencent, Alibaba, Baidu, and right? So among themselves, who do you trust more? Or when we talk about Internet of the world, we're adding up those big corporations. Who is the bigger one? Only the multiple parties has an issue of decentralized, which meaning the network, the Internet, has a problem with the decentralization, right? With a centralization or big brotherhood. So then, let's say we have only 5 big brothers, 5 big players of the Internet. No one trusts the other. How are you going to establish trust between them? Then this one, I don't trust that one. So, but then we have to trust this blockchain. We know, let's say Bitcoin, no one's controlling it. We can all create a wallet. And no one has the right, 5 big players, right? No one has the right to revoke the wallet someone created. No one has the right, to manipulate the data. The Bitcoin, how much coins do you have in your Bitcoin, right? So the 5 big players of the Internet saying, then can we say, you don't trust me? Then can we establish a protocol saying we all trust the wallets created on Bitcoin, correct? That's a fair way to put it. Let's say if the 5 of them agreed, then saying, okay, if Microsoft issuing ID, Google didn't like it. If Google issuing IDs, Apple doesn't like it, right? Then can we use the wallet being our common IDs? Is that fair? Correct? That's why we need to build a smart web. We build an Internet, given the blockchain to issue IDs, which is not manipulated by any of the players. And the problem with Internet today is that Internet, as I mentioned, Internet was designed either 1969 or 1970, right? At that time, at least the founding fathers of Internet made a very wise decision to make the Internet decentralized. No one's controlling the Internet. Anybody with a server, you know someone on the Internet, you connect to it, you're adding one more node to the Internet. So which make the Internet spread across the world, convincingly saying no one's controlling it. But the problem with the Internet is also decentralized, because everyone can have a server connect to the Internet, and then, let's say in the 70s, because all the nodes are controlled by research institutions, universities, and big corporations. But now, Internet is spreading across all countries and all individuals. Of course, we know there are criminals, there are sharks, robbery, and fake items, fake everything, right? So then that's why you see viruses spreading the Internet and the fake identities, and no one can trust one another. The problem is growing, especially in the Internet of Things, IoT era. We have millions of surveillance cameras, sensors all across the world. Let's say, how many of you know a smart light bulb, right? Like a Philip, those light bulbs sold in Apple stores, right? And people can make those light bulbs in China, right? So-called the circuitry, the motherboard for a light bulb. It's about $1, $2 each, built into the light bulbs, right? And if you screw those light bulbs, millions of them, into homes, because we all know there's a router, the router firewall is one-sided. It's like a one-side mirror. From outside the internet, you cannot see the devices inside your home. But on the other hand, all devices from your home can have free access into the internet. So if I screw those fake light bulbs, millions of them, into any country, right? The light bulbs at certain time, say, launch a DDoS attack, send network packets to any given website IP address in a loop. Basically, if you deploy 1 million light bulbs, you can attack any country, any website, just like that, right? The website's gone. Like what happened in 2015 December. If you do a little bit of research on 2015 December, the routers and surveillance cameras in the United States acting up and hit the dyn.com. And half of America, more than half of America is gone. Like Google, Facebook, Twitter, at that point, it's all shut off. Literally, okay? And which really literally meaning if you have that many light bulbs or surveillance cameras, any country is vulnerable to the attacks. So then, that's why actually 20 years back, we had this feeling we need a new operating system, right, to guarantee the security or safety of the internet. The solution, actually, that's the third problem or point I'm going to mention, is that we need a new operating system to share executables. Let's say Google has something called Instant App, and so basically we're sharing apps between one another, and also without fearing passing viruses, right? And also we have to guarantee the security or safety of the internet. The solution is actually very simple. We knew the solution 20 years back, is that no one is allowed to send any messages on the internet but the operating system. Operating system would be the sole mechanism or party which could send and receive messages. And we're making like Elastos open source under the scrutiny of everyone, but then pretty much like the blockchain, it's all open sourced, yet you cannot steal money from one wallet to another. And now we have the Elastos all open sourced and scrutinized by all developers of the world. Then no one actually can steal information from or the asset from like one hard drive to another, because the guarantee is by no one is allowed to send messages. Applications are not allowed to send network packets, right? It's very hard to grasp the concept to start with. And actually, it's not that sophisticated, because in the past, in current operating systems, the applications, when the operating system is called device OS. Device OS meaning I can only take care of the device. I can take care of the phone, or I can take care of the PC, or I can take care of the router, right? Because like Android, iOS, and Windows, they can all take care of the hardware. But then for applications which want to go onto the internet, it's applications' responsibility to find the server they're looking for. Operating system doesn't care. If you want to go onto the internet, they only provide something called a socket, basically providing a a entrance to the internet. But as if where you're going, operating system doesn't care. So you can send duplicate package to multiple destinations. Say, if I want a surveillance camera, should send the videos only to your phone, but the surveillance camera manufacturer took the liberty, make a copy to themselves, literally stealing your information. Currently, there's no one stop. No one stops the manufacturer from doing that, right? Say if the message could be only delivered by the operating system, then of course there's no backdoor to the manufacturer's website, correct? So that's how we feel it can, in a way, to a large extent, make it much harder to do piracy or to launch DDoS attacks. It's through something called metadata-driven remoting, called a reflection. The technology was very old, actually back into the Xerox years, 1980, by Smalltalk, they have this reflection, metadata-driven. It's there already. It's that old. It's not something new, okay? It's just people didn't, at that time, the hardware was not fast enough, the machine's not powerful enough, but currently all the capabilities are there. So we should be able to use something called a metadata-driven and taking over the network and having everything sent and received on something called a delegation. You delegate. You want something like let's say if I want to send a letter, I ask the mailman to do it, right? I don't literally go myself. So on a phone, virtual phone, right? Because if I want to make a call from one party to another, I dial a phone number. Then it's the AT&Ts and Verizons to do all the heavy lifting. It's called a carrier to send messages on your behalf. So that paradigm right now is applying to the internet. I'm not going to go into too much detail, but then what I'm saying is, given a phone number, we can find from one phone to another phone. If we talk fast enough, and we put one machine behind one phone, put another another computer behind another phone, actually we can do distributed computing without being able to hack the carrier. Correct? Anyway, that's the concept of it. So the technology, what I'm saying is, it's there. So I mentioned 3 points, right? And transferring value from one party to another, you cannot just transfer code. You have to transfer. You cannot just transfer data. You have to transfer code. So the value internet really is the internet of value is really internet of code, because there are only 2 things on your hard drive, data and code. The last internet is the internet of data. Now the forward-looking internet of value, actually is the internet of code. That's the point number 1. Point number 2, blockchain itself is centralized. The blockchain itself has nothing to do with decentralization or distribution. Decentralization and distribution, they are all about multiple parties. Only the internet has multiple parties, which needs to be decentralized. Shouldn't be controlled by any big brothers. All right? So that's the point number 2. Point number 3 is that we need a new operating system to take over the network traffics, so then we can find off viruses and piracy. Okay? Do I have more time or? Yeah. So now the 4th point I'm going to mention is talk about a little bit about blockchain. So I see blockchain has 6 characteristics, 6 points that I want to mention. And decentralized apps. What is a decentralized app, right? Comparing to app. App meaning something we can consumer use. The software interact with consumers is called apps. The software which not interacting with consumers are called services. On Windows, it's called foreground windows and background services. On Linux, called foreground applications and background daemons. But they're really mentioning the same thing. So apps really has something to do with consumers. There are four kinds of dApps. dApps meaning the apps without intermediaries, getting rid of the intermediaries, decentralized dApps, decentralized apps, the apps that without intermediaries. There are only 4 kinds of dApps. Who is the most evil? It's the media player who's doing the indirect piracy. Then who is the media player? By and large, all software are intermediaries. Because if you write a doc, you need a Word to play it, right? If you write a PDF, you need Acrobat to play it. If you write a H.264 movie, you need a media player to play it. If you have MP3, you need a music player to play it. So the software, by and large, is the most evil intermediary. We need virtual machines to fend off the piracy, right? So that's the first intermediary. Second intermediary is the website, client-server website. The website, somebody is writing the blogs. Somebody is producing the short videos. Who is manipulating? We know Facebook is manipulating, right? We know a lot of those websites that are manipulating the big data. They don't tell us the truth. As if the movie played 1 million times or played 10,000 times. They may not telling the truth. So the second intermediary, which could be evil, is the website. So services. Who's the third? The third being the carrier. Because we have surveillance cameras installed at home. We have our phones. We want to watch the surveillance camera of our home. But someone took the liberty broadcasting home video through the internet. That's the carrier being evil, correct? How do we get rid of the carrier being the evil, right? That's the third kind of dApps. Can we make the carrier autonomous running? As if it's a Bitcoin, it's autonomous running by miners. Side effect of making it run. That's the third. The fourth one being the website. It's most of the website, all of the websites today are controlled by one organization or one individual. Can we have the website controlled by a consortium, by consensus? So a website is controlled by multiple parties built out of smart contracts. Among the 4 dApps, which one, as I mentioned, I ordered them. The client, the media player being the most, and the website being the second, could play harm to consumers. The third being the carrier. Only the fourth being consensus-based websites. What I'm saying is, today when we do research on blockchain, they are only talk about one kind of dApps. That's a smart contract. So to me, that's the least important of the 4 evils, okay? Because that's all the time I have. I can only tell you the conclusions. That's all my talk for today. Thank you very much.